Work titled Lines and Circles Quiz Review. Let's get started with problem number 1 here. We need to find the distance between each pair of points. Leave your answer as a radical as needed. So in order to do this, especially when you have the graph, I think you should just create a right triangle and then use the Pythagorean theorem. Let's go ahead and do that. I'm going to create a right triangle right here. And label the sides A, B, and C. Always make sure the longest side, your hypotenuse, is C. Pythagorean theorem is A squared plus B squared equals C squared. And now to find these distances, we can just count the boxes because the graph here just has a 1-to-1 box ratio. So this is 1, 2, 3, 4, 5, 6. B is 6. This length over here is 8. Plug those into your formula and we'll get 8 squared plus 6 squared equals C squared. Finish solving this, we get 64 plus 36 equals C squared. 100 equals C squared. To get rid of the squared, we can take the square root of both sides. The square root of 100 is a nice even 10. So we'll simplify that to just be 10 and put a box around our answer. It's 10 units long. We don't know what sort of units there are here. It's just 10 units long. Let's look at problem number 4 next. Problem number 4, we've got the 2 points, but we don't have the graph. So one thing we can do, we can sketch a quick graph of this if we want. Let's say 2, 8, 1, 5, to kind of get an idea what this should look like. But mostly, all you have to do is to get the legs of your triangle, find the distance between your x values. That'll give you the bottom of the triangle. Find the distance between the y values. That'll give you one side length, and then again use the Pythagorean theorem. So this length right here is 1. This length right here is 3. 1 squared plus 3 squared equals C squared. 1 plus 9 equals C squared. 10 equals C squared, square root, square root. This one, 10, does not have a nice easy square root, so I want to leave my answer as the square root of 10. Raise your hand if you got a question. All right, midpoints. Some of us were getting stuck on midpoints. In order to find the midpoint, we want to treat the x and the y values separately and average them. So there is a midpoint. We can even fill it in to approximate it right there in this line. The x value of that midpoint is going to be the average of these x values, and the y value of that midpoint is going to be the average of these y values. So the average of x values, -1 and 2. These y values are -2 and 0. To find the average of two numbers, you can just add them up, divide by 2, so -1 plus 2 divided by 2. That equals 1 divided by 2, or 0.5. Which looks about right. The x value there looks like it's about 0.5. And then for the y value, 0 plus a -2 over 2, that's -2 over 2 is -1. And then we should always write our answer as an ordered pair, 0, 5, -1. All right, and if you're just given the points, same process, you're going to average the x values and average the y values to get your new x and y. The average of 10 and -7, let's see, 10 plus a -7 divided by 2, that's 3 over 2, that's 1.5. And the average of -9 and -3 is -12 over 2, or -6. For a final answer of 1.5, -6. That's your midpoint there. All right, now how do we find the other endpoint if we're given a midpoint? I'll do problem number 10. In order to find the other endpoint, we have to realize that this number here is the average between this endpoint and the other unknown endpoint's x value. So 1 and this unknown x are going to average to become a -10. 9 and this unknown y are going to average to become 0. So we'll just solve that algebraically. negative 1 plus x over 2 equals negative 10. And 9 plus 0 over 2, or 9 plus, I did that wrong, 9 plus y over 2 equals 0. Alright, to solve this, the first thing I would do is I would multiply both sides by 2, because the whole side here is being divided by 2, so multiplying by 2 will cancel that out. Negative 1 plus x equals negative 20. Add 1, x equals negative 19. Over here, multiply by 2, 0 times 2 is just 0. So we've got 9 plus y equals 0, minus 9, y equals negative 9. Questions? All right. Sketch the graph of each line with just the intercepts. We'll do problem number 11. The x-intercept is negative 4, so go to your x-axis, put a point at negative 4. The y-intercept is 5, so go to the y-axis, put a point at 5. We know this is going to be a straight line. I guess it doesn't tell us that it's going to be a straight line. On the quiz, we'll make sure to tell you that this is going to be a straight line that connects these 2 points. There's only one line that can go through those 2 points. It looks like this. We're not looking for the most precise graph of your life, just a sketch of the graph. All right, for 13 and 14, we need to find the x and y intercepts and then use that information to graph the line. This is the piece of information we need to know. At the y-intercept, x is equal to 0. The variables are kind of backwards. At the y-intercept, x is 0. At the x-intercept, y is equal to 0. So let me plug in 0 for x and solve. So now we've got 2 equals negative 2 times 0 plus y. 2 equals y, because this goes away. That gives me my y-intercept, so I can put a point right there. And now let's set y equal to 0. 2 equals negative 2x plus 0. 2 equals negative 2x divided by negative 2. Negative 1 equals x. That is my x-intercept. I've got 2 points. I can connect them up with a straight line. And that's good enough. I'll try to do it one more time. For problem number 13. So once again, at the y-intercept, x is 0. At the x-intercept, y is 0. Let's use that same information with the quadratic graph. Main thing we need to remember here, if we take a square root, you get a positive and a negative answer. So let's set y equal to 0. So 0 equals x squared minus 9. Add 9 to both sides. 9 equals x squared. Take the square root. Plus or minus 3 equals x. So I've got 2 x-intercepts, one at positive 3, one at negative 3. For problem number 15. And now let's repeat the process, but this time set x equal to 0, y equals 0 squared minus 9. 0 squared goes away. Y equals negative 9. That's our y-intercept. And the only way to connect these 3 points would be with a curved parabola. Do your best to connect up those points. None of these other points matter. All that matters is that it has the correct x and y intercepts. Question? One second. Why is it not working? Who knows? All right. Let's look at the circles for 17 and 18. First thing we need to be able to write these equations is the standard form of the equation of a circle. That equation is x minus h squared plus y, so in parentheses, y minus k squared equals r squared. You need to do your best to find the center of that circle. It's going to be an ordered pair. This point is at 1, -2, and that gives us an h and a k value to plug into h and k. And for the radius, we need to just count how many units it is from the center to any point on the circle. It should be the same no matter what. I'll just go straight up. I get 3 for the radius, so 3 is going to go right there. A 1's going to go right there, and -2 is going to go right there. And let's plug it into our formula and simplify. This minus and negative will become a plus, and this 3 squared will become a 9. X minus 1 squared plus y plus 2 squared equals 9. That's the equation for number 17. You use a very similar technique on 19 and 20. Let's jump down to 21. So we have the center, so we have h and k. The only thing we're missing is the radius. To find the radius, we need to find the distance between the center and the point on the circle. So I'll notice that the distance in x values is 6. The distance of y values is 2. So 6 squared plus 2 squared equals the radius squared. 36 plus 4 equals r squared. 40 equals r squared. I don't ever actually have to find the radius. I just have to find what r squared is, and we know it's 40. And now I can plug it into my formula. X minus h is going to become minus a -10, will become a plus 10, plus y minus -4 will become y plus 4 squared equals 40. Once again, to find that radius, I said to get from this x value to this x value, that's 6 units. To go from -10 to -16. To get from this y value to this y value, that's 2 units. And then I just plug that into my Pythagorean theorem, a squared plus b squared equals c squared. All right, what if we're given the circumference like we are in problem number 24? We have the center, so we have an h and a k. We need the radius. We need this formula here. Circumference equals 2 pi r, where r is the radius. So plug in this circumference right here for c. 2 pi root 14 equals 2 pi r. Cancel a 2 pi from both sides, and we get that the square root of 14 equals r. But at the end of the formula is r squared, so let's square both sides. The square root of 14 squared is just 14. 14 equals r squared. Plug everything into the equation. X minus -15, this is going to be x plus 15 squared plus y minus 6 squared equals 14. Alright, I think we should be able to do 25 and 26 using that information. Let's talk about converting to general form. In general form, there are no parentheses, so we got to get rid of these parentheses. I'll do problem 28. When I see that squared, that tells me to take everything underneath the squared and multiply it by itself. So x minus 7 over 2 times x minus 7 over 2. Is that expanded? And then y plus 4 squared is going to be y plus 4 times y plus 4. And then don't forget about this equals 1 over here. When I have a binomial multiplied by a binomial, I need to FOIL to correctly distribute that. So first, outside, inside, last. X squared, when I multiply my first terms, minus 7/2 x minus 7/2 x. -7/2 times -7/2 becomes a positive, not 14, 49 fourths. because we multiply the tops of the fractions and then we multiply the bottoms of the fractions. That's 49 over 4. Now let's distribute this one. So plus y squared plus 4y. So first outside, inside, 4 times y is another 4y. And then last, 4 times 4 gets me a 16 equals 1. And now I want to combine like terms. This here with this 16 over here. 49 divided by 4, that's going to be 12.25. Yep. And what do we got now? We got x squared, negative 7x, or 7 halves x minus 7 halves x will be negative 14 halves x. So negative 14 over 2x. We just add the numerators. Then we've got this y squared. Do a plus there. The y squared doesn't have a like term. 4y and 4y will become an 8y. And 12.25 and 16, that becomes a 28.25 equals 1. And now in the last step of simplification here, I want to simplify this fraction, and I want to bring this 1 over, because in general form it's all equal to 0. Also, I want to bring the y squared term closer to the front. So final answer, x squared plus y squared minus 7x, negative 14 over 2 is 7, plus 8y plus 27.25 after we add a negative 1 in. All right, moving on to the last page here. All right, find the slope of the line through each pair of points. We need to use the slope formula for this. y2 minus y1 over x2 minus x1. It's an x. And label your points x1, y1, x2, y2. So let's plug this all in. Negative 4 minus 3 over, and then so x2 is 14, then the formula has a minus, then I look what x1 is. X1 is a negative 13, so I get minus a negative. This is going to become a plus. And this here is going to become negative 7 over 27. That can't be simplified, so we'll just put a box around it. All right, so let's do this in a different direction. We have 2 points and a slope, but one of the values is missing. So still label them x1, y1, x2, y2. Plug it all into the formula. Negative 4 minus 9 over negative 3 minus x equals 13 over 2. Negative 4 minus 9, that's negative 13. So let me rewrite this over here. Negative 13 over negative 3 minus x equals 13 over 2. And to solve these equations, we call these proportions, we cross multiply. So you can draw a circle around this, you can draw a circle around this. Cross multiply it, negative 13 times 2, that's a negative 26. And on this side, I'm not going to multiply it yet, I'm just going to write it out as 13 times the quantity, negative 3 minus x. Distribute that 13, we get negative 26 equals negative 39 minus 13x. Should add 39 to both sides. And we get, what is that, 13 equals negative 13x. Divide both sides by negative 13. You get negative 1 equals x. So x right there is equal to negative 1. All right. The equation for this vertical line here is x equals 3. If I want to create a vertical line, it has to start with an x. I need a parallel line. So I'll put a line over here, or you can put it anywhere. This one is x equals negative 3. All right. Write the slope-intercept form and then draw a perpendicular line. So I'll do problem number 36. To find slope-intercept form, I need to know that it crosses at positive 1 here. That gives me my b value. And it has a slope of down 1, right 2. So rise over run would become negative 1 over 2 for my m. So that gives me an equation of y equals negative 1/2 x plus 1. So that's the equation of my line. Now to find a perpendicular line, I need to find the opposite reciprocal of this slope. In order to find an opposite reciprocal, you just simply flip the fraction upside down and multiply it by negative 1. That becomes a 2 over 1, which is the same as just 2. And so now I can put a line in with a slope of positive 2. And that will be perpendicular. I decided to put the y-intercept up here at 4. You could do anywhere along this y-axis. This is the line y equals 2x plus 4 for my perpendicular line. All right, let's do one last problem. Let's do problem 40. I need to write the equation of a line that goes through the point 2, 5 and is perpendicular here. If it's perpendicular, I need to find the opposite reciprocal of negative 1/7. Flip that over, flip the sign. My slope is positive 7. This point gives me an x and a y to borrow. I plug them into slope intercept formula, y equals mx plus b. And we get 5 equals 7 times 2 plus b. 5 equals 14 plus b. Take 14 away from both sides. Negative 9 equals b. And we get a final equation, y equals 7x minus 9. We simply borrowed this point to find our y-intercept, then we give it back, and we leave it as just the variable y and the variable x in our final equation here.